Today we will be doing section 3.4, x and y intercepts and linear inequalities. So what is an x-intercept? Well, it's pretty easy. An x-intercept is where the graph crosses the x-axis. The x-axis, there we go. So in essence, it is an ordered pair, where x is a number and our y is 0. So remember, when you're looking for the x-intercept, your y value is always 0. For your y-intercepts, that is where the graph, so let's put where the graph crosses the y-axis. So where the graph crosses the y-axis. And the way that is identified is through an ordered pair, where our x is 0 and y is a number. So our x value is always 0. X value is always 0. So let's go ahead and plug in 0 to find our x-intercept and our y-intercepts. For number 1, we will go ahead and let y equal 0. And let's plug in 0. So we have x minus 2 times 0 equals 4. And again, we're using this equation right up here for number 1. So x minus 0 is just x equals 4. So we put x is 4, our y is 0. That is our x-intercept. Our y-intercept, we will let x equals 0. So let's plug in 0 for our x, and minus 2y equals 4. We can get rid of that 0. Now we have negative 2y equals 4. Divide by negative 2 on both sides, and now we have y equals negative 2. Let's put that in our ordered pair. Our x is 0 right here, and our y is negative 2. That's how we find the x and y intercepts. Let's go ahead and try that same method for number 2. For our x-intercept, we will let y equal 0. So let's plug in 0 for, here, let me move this thing. Okay, let's plug in 0 for our y. So we have 3x plus 5 times 0 equals negative 15. So that 5 times 0 is 0, so we won't need it anymore. So now we have 3x equals negative 15. Divide by 3 on both sides. X equals negative 5. Let's put that in our ordered pair. Our x is negative 5, our y is 0. For the y-intercept, we will let x equal 0. And now we have 3 times 0 plus 5y equals negative 15. 3 times 0 is 0, so we will cross that off. Now we have 5y equals negative 15. Divide by 5 on both sides. Now we have y equals negative 3. So our x here is 0, that's what we plugged in, and our y is negative 3. We just found our ordered pair for our y-intercept. Now notice when you write the y-intercept and x-intercept, you should write it as an ordered pair. Don't just put negative 3 for the y-intercept. You need to put it as your x is 0, because that's what you plugged in for your x, and your y is negative 3, because that's what you plugged in for your y. So it should be an ordered pair. All right, let's go ahead and do number 3, the x-intercept here. Now we can find the x-intercept on this graph by seeing where the line touches the x-axis and the y-axis. So let's see, right here on the x-axis, I see it touches right here, where x is 1, 2, 3, at 3, right? So we can see x is 3, our y is 0. So for the x-intercept here, we have 3, 0. That is our ordered pair. For the y-intercept, I can see right here that the graph touches the y-axis. So remember, this is our x-axis, this is our y-axis. I can see that the graph crosses the y-axis at 0, where our x is 0, and our y is 6. That is our y-intercept. Let's do number 4. Well, I can see that the graph crosses the x-axis at that point, and then I can see that it crosses the y-axis at this point. So what is the ordered pair? Well, for the x-axis or for the x-intercept, I can see it crosses right there, but it's not definitely on a line, so I'm going to have to take a good guess here. And that looks like, well, I know it's 1, but it's definitely not at 2. It's in between 1 and 2, so that tells me it's about 1.5. So we'll just say approximately 1.5, which is 1.5. That's equivalent to 3 over 2. So let's go ahead and for our x-intercept, for our x, we will put 3 over 2, and our y will be 0. So that is our x-intercept, and again, it's just eyeballing it and seeing it's in the middle. Now for our y-intercept, we can see that the line hits the y-intercept at 0, -3, right? It's at -3 for the y and 0 for the x. So that would be our ordered pair. Let's go ahead and go to the next. Linear inequalities. So for linear inequalities, there are 3 things we should know. So number 1, plot your y-intercept and second point as normal. So let's put that down. Plot y-intercept and second point as normal. There we go. Number 2, determine, let's write this down, determine if the line should be dotted and in parentheses, these inequality signs, the less than or greater than signs, will tell us if it should be dotted. Those receive a dotted line, or solid. So, or solid. And you'll see the inequalities that say less than or equal to, or greater than or equal to. When you see those inequalities, you will use a solid line. So notice the dotted lines, that's not a good color. Let's try this with the yellow. The dotted lines will only be with the less than or greater than signs, whereas the solid lines will go with the less than or equal to or greater than or equal to signs. Number 3, determine which way to shade. So how do we do that? So determine which way to shade. So a very reliable way to determine which way to shade is to use a test point. I always recommend using the test point of 0, 0. You plug in 0, 0 for your x and your y, and if the answer is true, then you shade the side, with the point 0, 0. If it is false, you shade the opposite side of 0, 0. And I will demonstrate this for you. So shade opposite side of 0, 0, of the point 0, 0. Okay, so let's demonstrate this. Number one, y is less than 3x minus 4. So when we're graphing this, we're just going to use the inequality sign like an equal sign, just like we normally graph. So y is less than 3x x minus 4. So we go to our y-intercept, which is negative 4. Make this a little bigger. Let's go to negative 4. 1, 2, 3, 4. And then our slope is up 3 over 1. Up 3, 1, 2, 3. Oops, up 3, 1, 2, 3 over 1. There we go. So now we have our 2 points. You could even go up 3 one more time. 1, 2, 3 over 1. So that way you can draw your line. So try to draw your line as straight as possible. Connect those dots. Now notice our inequality sign. Will that be a dotted line or a solid line according to what we just wrote above? It would actually be a dotted line. So I'm going to write that right here, dotted. So I'm going to go through and make this a dotted line. Just using my eraser right here. So if you're doing it with pencil, you could just use your eraser to go through and make it a dotted line. So it's a dotted line. Now we have to determine, will we shade above or below? Well, remember I told you about the test point? There's our test point, that red dot. So let's test it out. Let's see. So we plug in 0 for our y and 0 for our x. Well, 3 times 0 is 0, right? So 3 times 0 is 0. So I could actually get rid of that right there. Now it's saying 0 is less than or equal to negative 4. Is that true or false? Is 0 less than or equal to negative 4? That's actually a false claim. So remember, number 3 says if it's false, you shade the opposite side of 0, 0. So I am going to go ahead and shade the opposite side, which is right over here for the line. Number 2, y is greater than 5 and negative 3x. Well, right here I can see my slope is negative 3. My y-intercept is 5. So let's go ahead and graph that. My y-intercept is 5, so let me plug that in. 1, 2, 3, 4, 5. And my slope is down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And we draw the line all the way through. Okay, now is it a solid line or a dotted line right here? So let's take a look. Well, it's a greater than or equal to, so according to what we wrote down, that would definitely be a solid line. So we can leave it solid. Now we have to determine which side do we shade on. Well, let's test our point 0, 0 here. So I have y is greater than or equal to 5 minus 3x. Let's plug in 0 for our x and our y. So minus our negative 3 times 0 is 0. So is 0 greater than or equal to 5? Is that true or false? That's actually false. Therefore, should we shade the side with 0, 0? No, because that's a false statement. We shade the opposite side. There it is. Okay, let's go ahead and do number 3. Now remember, one thing you need to do is make sure your lines on your graphs are nice and long, so when you do the shading, it will shade all the way through. I could have probably made that line a tiny bit longer, but just make sure it's long. Number 3, 2x minus 6y is greater than 12. You know what? I just noticed on the page, your book says something different. So I'm going to change mine to what your book says. And your book says y is greater than x minus 3. Okay, so let's go ahead and graph that. What is our slope? Well, our slope here is 1, and our y-intercept is negative 3. So let's go ahead and go to our y-intercept, negative 3, 1, 2, 3. And our slope is up 1 over 1, up 1 over 1, up 1 over 1. There we go. Do a line all the way through. Now let's notice what type of line? Will it be solid or dotted? Well, our inequality is a greater than sign, so therefore it would be dotted. So let's go ahead and go through with that eraser and make this a dotted line. Let me see if I can make my dotted line a little bit smaller. There we go. Okay, so there's my dotted line right there. Now I have to determine where I will shade. So let's go ahead. Let's plug in 0 for our y, 0 for our x. Now we have 0 is greater than -3. Is that true or false? Actually, that is true. 0 is greater than -3. So that is true. And again, we were testing the 0, 0 point out. So since it is true, we will shade the side with 0, 0. Number 4 is y is less than or equal to 3. Let's go ahead and graph this line here. Well, we can see our y, it's going to hit the y-axis at 3. 1, 2, 3. So let me move this up. 1, 2, 3. Oh, how did I get green? Let's go back to blue. Here we go. 1, 2, 3. All right, and it hits the y-axis all the way across. Now, is this line going to be dotted or solid? It will definitely be solid because it's a less than or equal to sign. And let's go ahead and determine if we will shade above the line or below the line. Well, if we were to plug in 0 for our y, is 0 less than or equal to 3? Let's see. It is definitely less than 3, so this is a true statement. Therefore, we would shade below.